Displacement, a 9th grade conceptual physics video. This is a picture by Harold Edgerton called Squash Stroke. This is known as a composite image because you can see many different images of the squash racket in one picture. In this image, we can see multiple squash rackets as Jack Summer serves the ball. Each image is the same time apart. Where is his racket moving the fastest? Where is his racket moving the slowest? In this section, the rackets are the farthest distance apart. We call the change in position from final position to initial position displacement. This section has the greatest displacement of the racket. In these sections, the rackets are the closest together. We call the change in position from final position to initial position displacement. These sections have the smallest displacement. When the racket travels the smallest distance in the time between flashes, when it has the smallest displacement, it goes the slowest. When the racket has the largest displacement in the time between flashes, it travels the fastest. Here's another question for you to check. This one is also by Harold Edgerton and is called Bobby Jones High-Speed Photography Golfing. Where does the golf club have the largest displacement? And where is the golf club moving the slowest? Try to figure it out and pause the video before going on. The largest displacement is where the golf club is moving the fastest, the red section. This should make sense because you want the club to be going as fast as possible when you hit the ball. The area where the golf club has the smallest displacement is where the golf club is moving the slowest, the blue section. This should make sense because it is in the very end of the swing where the club has slowed down. Mathematically, displacement is described as delta x. Delta means change in, and x means position. We use x when we're talking about the horizontal position. We use y when we're talking about the vertical position. So delta y would indicate change in the vertical position. Delta always means final minus initial. So delta x is x final minus x initial, the final position minus the initial position. Imagine there's an imaginary number line on a road. A person is walking down the road. She starts at position 0. The initial position, x initial, is 0 meters. Then our person moves to position 10. The final position, x final, is 10 meters. Her displacement is final minus initial position, or 10 meters minus 0 meters. She has changed her position by 10 meters. But what if our person moved the other way? What would her displacement be if she started at 0 meters and moved left to the negative 10 meter position? Her displacement is final minus initial position, or negative 10 minus 0. She has changed her position by negative 10 meters. She has not moved a distance of negative 10 meters. That would be ridiculous. The negative sign in displacement simply means she has moved to the left. What is her displacement if she starts at position 10 and moves to position 0? Pause and see if you can figure out her initial position, final position, and change in position. Her displacement is 0 minus 10 meters, and she has changed her position by negative 10 meters. She has moved a distance of 10 meters, and her displacement has been negative 10 meters. Note that the displacement does not tell you where she ends up. It just tells you how far she has moved and in what direction. What's her displacement if she starts at position negative 5 and moves to position 10? Again, pause the video. Her displacement is 10 minus 5. She has changed her position by 15 meters. She's moved a distance of 15 meters and her displacement has been positive 15 meters. Positive displacement indicates she's moving to the right. What's her displacement if she starts at position 5 meters and moves to position 10 meters and then moves again to position negative 15 meters? Pause and see if you can figure out her final, initial, and change in position. Her displacement is negative 15 minus 5. She's changed her position by negative 20 meters. All we care about is the final and the initial position. We do not need the 10-meter point to determine displacement. If we wanted to find out her distance, we would need to include it, but not for displacement. Displacement is the same in the vertical direction as well. Our person could be climbing a ladder. She starts at the top, 5 meters, and climbs down to ground level, 0 meters. What's her displacement? 0 minus 5. She has changed her position by -5 meters. Negative displacements indicate you are going down or left or west or south.